32%. There is even a circular section formed from a series of double bends which can be driven non-stop. This means that we can now recreate alpine conditions in the heart of the North German plain using the minimum of space. 75 kilometers of arduous conditions of all types modeled on the entire cross-section of roads encountered across Europe. Each part section has been built in the same manner as an original road in a public highway system, so that the vehicles can be tested in conditions that are identical to the original. Dangerous curves, ridges of different lengths, potholes, blue basalt and cobbled surfaces, humpbacked bends, cambered and uneven road surfaces, and roads that have been worn away by the stress of traffic and heavy goods vehicles. Sharp bends, a speeded-up test section for rapid test results. A tortuous route for any vehicle, consisting of two symmetrical hemispheres, which help to produce even vehicle loading. The dynamic section, 500 by 500 meters and absolutely smooth, absolutely seamless for all kinds of extreme tests. All in a day's work on the test track. Loading vehicles for functional and fatigue strengths. At the moment, there are 110 vehicles being tested. Each one has its own carefully prepared test program. This test driver is preparing his vehicle for a 100,000 kilometer test. Just like on the public highway, the rules of the road have to be observed, and all roads have to be reached via roundabouts. This section has been designed as a one-way road, as the cars travel at high speeds along it. The stresses on cars are enormous. All results and measurements, all reactions and experiences of the drivers are logged and evaluated after each test, for a single fault in a new car is one fault too many. The endurance test track conceals a great many obstacles for the test cars. This enables weak points to be identified, for instance in the chassis design. The hilly area also forms part of the endurance test track. The cars pass here every hour. The gradients enable the design of the transmission system and the engine to be tested, both with and without the additional use of trailers. The heat behavior of the engine, radiator size, wear and tear on the clutch and the like can be studied here. Tests with trailers are carried out on gradients of up to 30%. The inner circuit is also used for corrosion testing. The vehicles drive through a carefully designed series of track sections containing loose chippings and saltwater spray systems. They have to pass through saltwater spray chambers, drive through mud and sludge, and then be able to withstand the extremes of rigorous winters and tropical heat. In between all this, there are regular functional tests on doors and locks and on hinges. And then it's back onto the road. This kind of test simulates the corrosion to which a vehicle is subjected when the vehicle is exposed to loose chippings, salt, water, heat and cold throughout its working life. Not all of the employees at the test track are drivers. Members of the security services are responsible for making sure that unauthorized persons cannot gain access. Here, secrecy is of the essence. The 100 kilometers of roadway on the test track are kept up to standard by a team of maintenance workers who carry the same equipment as their counterparts on the national highway system. In addition, the area contains some 850 hectares of woodland, which is maintained to professional forestry standards. The test track even has its own sawmill, and the wood is sold on the commercial market. A series of fire stations are distributed throughout the area, and these are all manned during hot, dry weather. No smoking is allowed on any part of the site. It goes without saying that the test track has its own rescue services and also its own firefighting services. It all comes together in the control area. It is from here that all activities are monitored and supervised. The most tortuous part of the test track has its own built-in system of chicanes, which really pack a punch. Some of the cars that are tested here spend their entire service lives on this part of the test track. A Passat on the Hydropulse test stand. All of the irregularities of the ERA test track are stored in the computer. The vehicle bodywork undergoes the same kind of treatment here as it does on the track itself. Within a matter of days, the stresses on the vehicle components and structures that could eventually lead to a failure of the entire vehicle can be simulated on the Hydropulse test stand and on the other equipment. For example, a total of 180 hours on this test stand is roughly equal to a test of some 100,000 kilometers on the most tortuous part of the entire track, and that's just about half the anticipated service life of a car over the years. Although it's true that a lot can be achieved through the use of a test stand, there is no real substitute for the human operator, the roads, and all of the combined environmental influences. The tortuous track is in itself like a speeded-up piece of film. It can produce the desired results in a very short period of time. But the stress on the driver is also considerable. For this reason, all drivers are required to have half an hour's rest after every hour of driving. This is the 5th time today that this driver has been on the inner track. By the end of his shift, he will have covered about 750 kilometers. After 2 hours of concentrated driving in the 100,000 kilometer test, the drivers have a break of 2 hours. Special tests on the ABS section. The ABS system contributes greatly to an increase in active traffic safety, and for this reason it has its own special place in the test program. Five laps around the test track, that's 100 kilometers. Tests are carried out at all speeds right up to the maximum. A wide range of measurements are possible on the fast track. For example, acceleration, top speeds, petrol consumption, braking performance, and all acoustic and heat tests. The steep bends enable speeds of up to 200 kilometers per hour to be covered without the effect of lateral forces. The driver can even release the steering wheel, and the car will continue along its trajectory automatically. It rains a lot in Eire, but that can only be a good thing for testing cars. People don't only want to buy open-top cars for sunny days, and so tests are carried out in all kinds of weather. 200 test drivers are used for special non-stop and individual tests in 3 shifts over 24 hours. 20 million test kilometers each year on a test track that is unique in its versatility. Success depends increasingly on improvements in technical design. Safety, service life, corrosion protection, and energy economy all require improvements in design and construction. And even during the night, while the rest of us are asleep in our beds, they are still testing at the Eire-les-Cygnes test track.
After automotive engineering got on its feet, initial efforts were devoted to increasing engine power and performance. The engines became stronger and the cars faster. Race drivers of the era became celebrated stars. Few thought about safety during the fascination with speed in the 20s and 30s. Increasingly heavy traffic brought about an increasing number of accidents, and inventors had a field day. Engineers in the automobile industry were more realistic. The safety of these cars was improved step by step. Here, original films of safety testing at Auto Union from 1937. Today, safety is designed by computer. Crash tests show whether safety goals established for new models were achieved. In Wolfsburg alone, more than 150 new cars and prototypes were totaled in accident simulations each year. The automaker's job is influenced and guided by a flood of legal requirements. Each country has its own regulations, which all too often conflict with those of other countries. Official government certification represents the successful completion of the developmental process. Official certification tells the manufacturer that its new car complies with a wide variety of requirements, including those related to safety, and that series production may begin. During the years preceding, the new car had to pass a gamut of tests, such as static tests to evaluate the strength of the body, sub-assemblies, and individual components. All of these tests are carried out according to exacting requirements. Government agencies receive all test results, and for many tests, officials are actually present. The frontal impact into a fixed barrier at 30 mph has become a standard test for all passenger cars. A Volkswagen engineer responsible for passenger car safety regulations, Klaus Kruger, on this test procedure. We do not consider this test procedure to be entirely realistic. Statistics show that few vehicles are involved in 100% frontal impacts. For that reason, we also test our cars in a 30 mph, 30-degree angled barrier collision, and that with dummies.
Und mit Insassen.
It's obvious that vehicle structures have to be specially designed for this angled impact and higher test weight, and therefore offer more safety. And we demand even more of our cars. In a 30 mph barrier impact, all occupants should have a realistic chance to survive without serious injury. Impact energy should be dissipated gradually and gently, as well as in a manner which is tolerable for vehicle occupants. The forces acting on the head, chest and femurs should not exceed specified levels. All of this largely depends on the design of deformable structures, but most important upon the use of seat belts by the driver and all passengers. The following scenes are dedicated to those who do not wear seat belts. In an impact, everything happens within less than 1/10 of a second. The unbelted occupants continue to move forward at the pre-impact speed, obeying universal laws of inertia, until they hit the now stationary vehicle interior with the full brunt of the impact. Even rear seat passengers should always wear seat belts. Otherwise, they will not only endanger themselves, but also those sitting in front. The effectiveness of seat belts is not in dispute. These lifesavers permit vehicle occupants to take early advantage of the soft deceleration provided by deformable vehicle structures and protect them from the consequences of an uncushioned impact. But unfortunately, many forget to buckle up. Many others believe seat belts to be cumbersome. For that reason, many have placed great hopes in so-called passive restraints. One of these is the airbag. It couldn't, however, fully meet expectations. The airbag does not provide consistent levels of protection in various types of accidents, and its complicated technical systems are not easy to check.
We have
developed a passive restraint system which has proven itself well and which we have already installed in over 500,000 vehicles sold to date. The shoulder belt automatically moves into position when you get into the car, and together with the knee bar, restrains the lower torso via the knees and thighs in an impact. Dummies from the largest and most expensive collection in Europe stick their necks out in these tests. Anthropomorphic dummies, as they are technically known, measure the forces which a person could be subjected to in an accident. They are equipped with highly sensitive electronic measuring devices which record forces occurring at various parts of the dummy during an impact. Data from up to 96 channels are transmitted either online for immediate computer evaluation or are recorded digitally for later analysis. The tests themselves are for the most part highly automated. In this manner, precise data can be gathered regarding all phases of the crash so that accelerations, pressures, and other aspects of the crash can be precisely measured. The data then serves as one focus for further research and design efforts. Special high-speed cameras, which record the impact at up to 1,000 frames per second, are used for visual evaluation. They provide films which make it possible to observe and evaluate these lightning-fast events. In addition, marks exposed onto the film document the timing of individual events during the course of a test. New car designs have to demonstrate their ability to provide good occupant protection in other types of simulated accidents as well. The rollover confirms the effectiveness of the restraint system as well as the strength of the roof and its supporting pillars. The passenger cell must be strong. The rear impact shows how much energy is absorbed by vehicle structures and whether the fuel tank withstands the impact without leaking, as here on the Polo or on the Golf. Things are literally turned upside down as the crashed cars have to prove that the fuel system does not even leak in unusual vehicle positions. No fuel leakage may occur. Furthermore, the fuel tanks themselves, which are now increasingly being made of special synthetic materials, permitting better forming and larger volumes, have to pass special tests. Cooled to -22 degrees Fahrenheit and filled with test fluid, they must withstand a severe pendulum impact, as well as the intense heat of a gasoline fire. By the way, virtually every safety-related component must receive individual type approval, as evidenced by special markings on the parts themselves. The search for new materials with better properties than traditional steel plays an important role in the vehicle's safety field. Take bumpers, for example.